So we're going to start with our functions and properties that we were taking a look at yesterday. And just a couple of reminders. When we talk about evaluating, evaluate is just a fancy mathematical word for solve this. And we chatted a little bit yesterday about how I have two options and how I could do this and how we kind of knew what most of you were going to do. The easiest way to tackle this is to use change of base, which is where we let the calculator do the heavy lifting while we just have to punch the numbers in the right direction. So I'm going to kind of show you both, and then you can kind of figure out your way that you're going to want to tackle this. So one way you could do it, we'll kind of split this off, would be to say, okay, what power do I take my base to get this answer? Now, there are not many people, including me at times, that could be able to do this really easily off the top of their head. So what we typically are going to do instead is we're going to do what's called change of base, which basically is just we take the log of what we call our big, the log of our of value, okay, this one on the right, and we divide it by the log of our base. So the way we kind of like to look at it is log of big divided by log of little. So when I go to do this, and again, the log button is right next to 7 on your calculator. I'm kind of jumbo-sized here, so it might not be quite as easy to see. So we get that in there and set. We hit enter. We get our answer. And just to let you see, when I was looking at it with my other method, I could also do 7 to the negative third. Oops, I did the wrong thing. Oh, no, I didn't. Ooh, let's see if Math Enter Enter works today. Hey, there it is. 1 over 343. I got the same thing either way. So they both work, but I would probably guide you more towards change of base to make that a little bit easier. So that's how problems 1 through 4 are all going to work. When we get down to the next piece, okay, expanding and then condensing our logarithms. We chatted a bit yesterday about there's kind of a 3-step plan that we're going to work with here. When we're looking at these, we're going to check out the quotient or the divide part first. Okay, fractions are also considered for that. Then we were going to look if there were any products. And finally, we were going to check on power to power. Now, when I'm doing this, and again, the note sheet from yesterday kind of breaks it down a little bit more. When we're doing quotient, we're going from divide to subtract. When we're doing product rule, when we're doing expansion, we're going from multiply to add. And when we do power to power, we're going from exponent. I have a feeling I'm going off the screen. I am. We're going from exponent to coefficient. And the reason I want to get that written out here this first time that we do it, for the most part, is when we go to do the other direction, when we go to condense in a little while, it's going to be just the opposite. So this is going to be kind of a nice thing for us to look at. But this is something I got to kind of work at so I can make sure when it comes time to do it on the quiz, I can remember kind of how this runs. Am I willing to put, like up on a board or something, quotient, product, power to kind of give you some guidance? Sure, but I'm not going to put symbols and what they're supposed to do. That's something you're going to need to be able to know and work with on your own. So let's do a couple of these. And there's one exception to the rule, and that's what I'm going to kind of pound on the couple that we do here together at the start. And that is if we run into a situation like we do in 5 or 7, okay? What if there's an exponent on the outside? Because normally with an exponent, we swing it down to the front, unless there's parentheses. If there is, my job first is going to be to get that exponent sent through there, like I do with exponent rules. So this is going to be log base 8, and I'm going to have u to the 15th, 3 times 5, power to power, and v to the 5th. So now I can actually start doing my rules. So I look first and I say, okay, do I see any division? Do I see any fraction bars? No. Okay, so I don't have that one this time. Then I switch to product. Do I see multiply? Ooh, I do. So multiply turns into add. So here's what that's going to look like. So I'm going to have log 8u to the 15. Where I see the multiplication dot is where my plus is going to go. And then I have to rewrite log base 8 again. Because otherwise I'm changing the value of my answer. Okay, so I didn't have any step 1. I got a step 2 here. And then my last one is my power. If I see exponents, and I do still, those are going to become coefficients. So when I get to my last step, that 15 is going to go in front of my log base 8. There will be no exponent on my u anymore. It moved. And plus, this 5 also becomes a coefficient. And once I'm through that third step, I'm done. Okay? And then the other one I want to take a peek at with you, because it's kind of strange, is number 8. Because like, woo, you got like a radical working here. That's kind of odd. So how's that going to work? Okay, first thing we're going to do is we're going to rewrite this. Sort of like what we did with number 5. Now I don't have an exponent out here that I'm working with, but this radical looks kind of weird. So I look at this, and I remember way back to when we were doing radicals before, and we were going from radical form to exponential. So when we do that, we would always do the exponent over the root. So this is really x to the 1/3. Now, if there had been no number in here, we assume it's 2. It would have been x to the 1/2, because that's how we do square root. So here, I don't have an exponent out here to play with, so I don't have to worry about that. So what we're going to do instead is we're just going to start going down our list. Do I see any divide? Nope. Do I see any multiply? I do. So the multiply, log base 4z squared, the multiply is where my plus comes into play. And then again, we repeat the log 4 with my x to the 1/3. That gets me through step 2. And now step 3, do I have any exponents? And if I do, they come back to the front. So my 2 will go in front of my log. My 1/3 will go in front of my other log. And I'm set. But it's like anything else. I've got to get some practice with it for it to start making more sense. And I'm going to have some falls and some struggles here and there until we start to get that locked down. Now, as I was saying at the beginning of this, these same 3 things are going to be going on when we get down to condensing, except they're going to go in the opposite order. So I'm not going to rewrite all the other little stuff, but I am going to rewrite and just remind us when we get down to here, okay, when we condense to a single 1 logarithm, we do power first. So if we have coefficients, they're going to become exponents. We're going to do product second. So add will become multiply. We're just doing opposites. And then quotient will be last. Minus will become divide. So everything's the same. It's just we're doing it in the opposite order. So we'll do a couple of these. So let's see here. Can I keep that in? Okay, quotient's going to get cut off here for a minute, but we'll come back. So let's say I'm doing number 9. Okay, first job. Okay, power. Do I have any coefficients? I do. Those are going to turn back into exponents. So here, I'm going to have log base 9 of x cubed plus log base 9 of y cubed. Okay, I'm going to do things in pieces. So then I move to number 2. Okay, product. Now again, we're going backwards from what we did up above. So now, do I have any pluses? Yes. They're going to turn into multiply. Okay. So I'm going to have log base 9 x cubed plus turns into times y cubed. You're like, why aren't you writing log again? Our goal is to get it into one log. And that's what we have here. And then do I have any quotient? Do I have any subtract? I don't. That one's done. Now, as I'm doing some of these, okay, because we're going to do number 11 as well, and 12, because 12 is just weird looking. I want to make sure we don't get messed up. When I look at 11, I see a lot of similarities to number 9. I go, okay, I do see a coefficient that needs to move up. That's my power. So I get that done first. And I usually suggest that people don't try to do multiple steps at once, because that's just kind of where we get messed up with some things. So once I get there, product, do I have any add? Nope. Quotient, do I have any subtract? Yes. That turns into divide. So, x to the 6th, there's my minus. And it becomes divide. I'm down to one log, one fraction, and that's what we're looking to do. Now, the last one I'm going to do with you up here is going to be the weird one, okay, 12. I wish we'd have had a little more room, but some bonehead, oh wait, that would be me. Didn't leave enough room here. So the thing that tends to get people on this is they look at this and they're like, well, wait, that's division already. That's kind of weird. Let's rewrite this for a second. Because when I take something and divide it by 2, it's the same thing as multiplying it by a half. And that is going to go along with what we're doing much better than leaving it in that fractional form. Because by doing this, what it's going to allow me to do is it's going to take all of these coefficients and turn them all back into exponents. My first one's not going to change at all. But my next 3 all are now going to have an exponent on them. Okay, so A, B, and C all are going to take that 1/2 coefficient and turn them into 1/2 powers. Okay, so that's going to take care of my step 1 with these. Okay, coefficients to exponents. So then I can start working on my last 2 pieces of this to see how this is going to go. So I start looking. I'm like, okay, number 2 is product. Do I have any plus that's going to turn into multiply? Well, yeah, it looks like I have a lot of it. So as I go to turn this into a single logarithm, so I've got d, now I have a plus, it becomes times, a to the 1/2, and I got a plus, it becomes times, b to the 1/2, and I got a plus, that becomes times c to the 1/2. So all those pluses just became multiplication dots. But it's all 1 log now. And I don't see any minuses anywhere. So I'm done. But your big thing here again, I'll give you the quotient product power part. You've got to keep straight what that means. Okay, so when we're condensing, power goes coefficient to exponent, just the opposite of what we were doing up above. Product goes plus to times, and quotient goes minus to divide. We roll that out. Okay, that's more of a kind of an outline of what we were up to yesterday. There's more of those in yesterday on the note sheet, the video, and then some of the book problems to do. The back of this is more of what we were doing the prior days, so we're kind of hitting that again as well. So as we flip over, we're going to name the transformations, again, transformations, fancy mathematical name for shifts, okay, up, down, left, right. Identify the domain and range, sketch the graph, okay. We're going to do number 16 together. Now, reminder, and I'm going to put this up here at the top too, but this is something you're going to have in your brain. When you're doing these, and I know we've said this over and over and over, but I can't say it enough times because if we've got this down, it makes this so much easier. When I'm looking at my shifts, my left and right's what's in the parentheses. That's going to be important to us when we're doing these. That's going to be our focus. And then our up-down is going to be our k value, our value that's not in the parentheses. Here's why that's important, besides the fact that that's one of the questions on here. When I go to figure out what direction my graph's moving, and I can look at this and go, okay, it's going right 1, because minus inside is right, and down 4. The one that I'm going to lock in on is the left and right one, and here's why. And I'll show you on the calculator on this first one too, even though I think you'll see as we do this, I can do a lot of this without the calculator. So if I type this in again, log right next to the number 7, even if you have a fancy phone calculator, normally if you turn them sideways, you can get the logarithm stuff to come up. Oops, and I put too many parentheses in there. That would have been a problem. We talked about before, when I'm looking at my chart, I'll start seeing these error messages as I flow through. And there's always going to be a connection between the first error message and my right or left. Because normally, my graphs are going to start with an asymptote at 0. But this moved right 1. So if we start at 0 and we move right 1, my asymptote, my little wall, is at x equals 1. That'll always be a connection, my right or left and my asymptote moving. That also is going to make a connection for me. So my vertical asymptote is at x equals 1. Okay, x equals is the equation of a line. that's always going to connect with my domain. If this moves, so does my domain. So if I'd have gone left 3 and this would have been negative 3, so would this be. So they're all connected to each other. And my range is always the easy part with these. It's infinite. So logs, left and right, is going to be my key. So you're like, okay, what have I got left to do? Well, I need my points. And we've talked about a couple of ways I can get my points for this. And I'm going to show you both. One way when I sketch my graph is to take my two parent points, okay, 1, 0 and 10, 1, and shift them. So what do you mean? Well, what I mean is right 1 is going to affect my x. If I go right and I'm at 1, it gets me to 2. If I'm at 10 and I go right 1, it gets me to 11. And when I look at the down part, okay, if I'm at 0 and I go down 4, now I'm at negative 4. If I'm at 1 and I go down 4, I'm at negative 3. So those would be my 2 points. And I know sometimes you got to guesstimate a little bit. It happens. And I'll get that drawn in. Now you're like, okay, Harty, I don't like this whole shifty thing. And some of you, I even had plot these 2 points and then shift them, which works. If you'd be more comfortable going to 1, 0 and 10, 1, and then going right 1 and down 4 and make a new point. Go right 1 and down 4 and make a new point. That would work. Or if you want to look at your chart. Okay? Because what are you going to find in here? You're going to find there's going to be 2 points that have whole numbers. 2, negative 4. And 11, negative 3. I can always use the chart on the calculator. Okay? I have options. But no matter what, I still need to understand how this value connects with the others. Because the picture will tell me some, but it won't tell me everything. And when I'm looking at your graphs, when we get to the quiz, I'm going to be looking to see if your points are accurate and that you're not just kind of just throwing something on your paper. That ain't cool. Gotta get that done. So the last part of this review is going to be down here at the bottom. Okay, we're going to rewrite some things in exponential form and then in logarithmic. So here's what I've got to remember. And we've labeled these before too. I'm going to do it here as well. The little number down here is always my base. The value on the equal side is always going to be my exponent. And this is always going to be my answer. So when I'm doing exponential, I do base to the exponent equals my answer. And we've talked about how when it's all numbers like this, it's easier because I'm actually going to be able to double check. So I look at this and I go, okay, 18 is my base. That is my exponent. I think this is my answer. Now, can I check to see if I actually did it right? Yeah. Because if I did it right, this should be a true statement. I should get 18 squared, and when I hit enter, I should get 324. Woo! If I do that and I punch it in and I don't get a true statement, it means I did something wrong. I got to go back and check it out. So that's how that set goes. And then what I'll normally do is, and again, I've said before, this is kind of like cheating, but not really. When I go to rewrite it in logarithmic form, I'm going to go from exponent back to this. So what I like to do is kind of eyeball it, and I go, okay, so the 16 is my base. The base goes here with my logs. So log 16, little 16. Okay, the answer is what goes next to it, 256, which means the exponent goes over here. Can I check this? Yeah. How do I check this? Do I just type it in this way? Remember, when you go to type it in, remember to change a base? The very first problem we did on the front, that's what I'm going to do here to check it. Log 256. log big divided by log little. I should get 2. I do. And I'm set. So that's what we're taking a peek at here. This is what we're trying to work through, kind of make sure that we're feeling all right with this. So what you need to do right now, okay, again, about 15 minutes, you should at least be able to knock out a problem, an additional one from each of the sections, and check them to make sure that it's going okay. Because if you just sit back, it is not going to get better. If all you do is gap, it is not going to get better. As all you do is stare at your phone for the next 10 minutes, that is not going to get things better. You practicing will, okay? And if you check your answers and it doesn't work, come see me. Let's get this straightened out. Let's get this set, but come with something on the paper.